Hello, welcome to the Python class. So this class is going to be a 4-day class, and it's roughly about 3 hours sessions. There's going to be some pauses in the middle where you would be responsible for answering some questions. Okay, so let's get started. So I'm gonna skip all this boring stuff. And we'll jump into this part. So in this class, we will use a tool called REPL, and what it stands for is read eval print loop. And I will show you guys how to sign in. So you have to log in, and then you can log in with email. Great. And then you want to click on new REPL, search for Python, and then create REPL. Great, awesome. So now this is the Python REPL on the right here. So we can ask it questions like 1 plus 1, and it'll give us an answer of 2, and that's basically it. So before we continue, you should try to get the REPL opening on your computer using the steps on this page, and try to enter in this and see what the answer is. So just pause the video, and then when you're ready, continue. Okay, great. So what is this answer? So when we compute this, when we multiply, we have to multiply first. So 2 times 3 is 6. 6 plus 1 is 7. We can check it here. 1 plus 2 times 3. Yes, that is 7. Great. Awesome. And there are a lot of other operations that we can apply to math, to numbers. We can add two numbers together. We can subtract two numbers. We can multiply two numbers, divide two numbers. We can negate a number. For example, if a number is -8 and we negated it with a negative sign, it becomes +8. We can also ask for what the remainder of a number is. For example, if you can ask, what is the remainder of 4 divided by 3? That would be 4% 3. And the answer to that is 1, because yeah. And you can also do an exponential. So if you want to find out what the cube of 10 is, you can do 10 star star 3, and that will multiply 10 by 10 by 10. And you can also use parentheses to prioritize operations. Okay, and this is basic math. If you remember PEMDAS, or is it? Yeah, PEMDAS, or PEMDAS. It's a mnemonic for remembering the order of operations. Okay, given this, I have a couple questions, and what I want you to do is work together to, I guess you're on your own, but what I want you to do is try to guess what the answer is, and then when you're done guessing what the answer is, you can enter the answer into your REPL and see what the result is. You can pause the video right now to continue with that. Okay, great. So let's execute this code. So 1 plus 1, that's 2. That's to be expected. 1 minus 1, that's 0. Great. No surprises. 1 times 0, that's 0. Cool. 1 divided by 0, this gives us back an error. In some languages, this would not be an error, but it would silently continue to execute your code. But in Python, an error is raised when you divide any number by 0 because it doesn't really make sense. 1 plus 2 times 3, that's 7. We did that already. 10 mod 3, that is the same thing as taking 10 and doing continuous subtraction until we get a number less than 3. So 10 minus 3 is 7, minus 3 is 4, minus 3 is 1. Great. And 3 squared is 9. So great, awesome. And then this is 10 plus 3, but then we negate it, so that should be 13. And this last one is 1, but we negated that 1, so that's -1. And then we negate that 1 again, so that's +1. Great. Okay, so another thing that we can do is we can compare numbers with each other. For example, we can ask for is 1 greater than 2? That's not true, so we'll get a false back. Is 1 greater than 0? That is true, so we get a true back. And there are these many operations. We can test if a number is greater than another number, a number is less than, number is greater than or equal to, less than or equal to, exactly equal to, or not equal to. Important note is that this has 2 equal signs. If you had only 1 equal sign, that would actually be a different operator. It would actually be a variable assignment operator. And that is going to be a different, that's a completely different thing that we will learn in the future. Great. So given that, let's try to guess what these will result to and also produce, or I guess enter these into the repo and see if your answer makes sense. You can pause the video to do this right now. Okay, great, we're back. So the first question is 2 plus 2 greater than 4. The answer to that is, we can reduce this to 2 plus 2 is 4, so is 4 greater than 4? That answer is false. We can check it with the REPL. 2 plus 2 greater than 4, and it's false. Next one is 2 plus 2 greater than or equal to 4. That will reduce to 4 is greater than or equal to 4. 4 is equal to 4, so this should return true. Greater than or equal to 4. Great. Next one is 1 less than 2, less than 4. So this can be separated to 2 statements. Is 1 less than 2, and then also is 2 less than 4. Both statements are true, so this should also be true. 1 less than 2, less than 4. Great. Next statement is 2 plus 2 not equal to 4. 2 plus 2 is 4, and 4 not equal to 4. That's false, so this should return false. And the last one is 2 plus 2 equal to 4. And that is true. Great. Okay, let's continue to the next section. The next section is functions. So Python has some built-in functions that basically takes inputs and computes some, does some logic and returns a value. So here's an example of a function. It's called abs. It's the returns the absolute value of a function. So to use functions, we type the function name, and then we have open parentheses and close parentheses right here, and we enclose the parameters within the function. So we're only passing a -1 in, so we're enclosing that within the parentheses. And when we call this, we get a 1 back. So let me show you that. Abs of -1, get 1. Great. So a function could have multiple variables, in which case we do the same thing. We use the function name, we have the parentheses, and then we have the inputs separated by a comma. So max is a function that returns the maximum value of all its inputs. So max of 2 and 4, that would return 4. I can show you this, 2 and 4, bam. Great. So Python has a lot of built-in functions. For example, the apps function, round, min, and max function. So given this, I want you to look at this and try to figure out what is the result of these questions and enter them in the repo, see what you get. And pause the video to do this. Okay, great. So now we're back. What is the apps of 10? So 10 is already positive, so it should return 10 back, right? And yeah, it does. And what happens when we round 1.6? This should round up to 2. Let's see if that's what happens. Yep, it does round to 2. What is the min of 1.7 comma round of 1.6? So the way to think about this is that when we have nested functions within each other, a function calls specifically, we would execute the arguments before we can call the function. So if we call round of 1.6, that returns 2, and the min of 1.7 and 2, that would be 1.7. 1.7 and round of 1.6 is 1.7. Great. Okay, now to the next section where we will write our own function. And this is what a function looks like. Let's dissect this a little bit. So this function has the def keyword, which just denotes that this is the start of a function. It has the function name, which is in this case sum, and it has arguments separated by commas. So this function takes in 2 arguments, x and y. And it also has a colon right here to represent a new code block. So it is important that every function definition has all these, looks exactly like this. It has the def, the function name, open parentheses, arguments, close parentheses, and colon. And the next part is the function body. In the function body, it needs 2 spaces, or 4, but you want to be consistent on 2 or 4. You never want to use 2 and 4 in the same function or even in the same file. So I recommend just sticking with just 2 spaces. Okay, and then the in your function you will have one line of code, one or multiple lines of code that will have a return keyword. This return keyword signifies to the function that this is going to be the last line that will be executed for this function. And the return statement will also sometimes have a return expression. So whenever we call the sum function, the output of the sum function will be this line of code. Great. So I'm going to write this function and run it, and we will be able to use it within the REPL application. So let's see. So define my sum of x and y, and then we want to return x plus y. Great. And when I press run, this interpreter would refresh, but now it has my function. And we can call this function with our 2 variables, and it returns 1 plus 2, which is 3. Important thing to note is that if we have multiple lines, we can have multiple lines in our function. Let's say we want to print the x variable, and then we want to print the y variable before executing our code. We can definitely do that. So my sum of 2 and 3, this should print out 2 and 3, and then it should return 5, and the read eval print would print out that 5. So that looks good. So this is all part of the function body, and it all is prefixed with 2 spaces. If we don't prefix with the 2 spaces, what ends up happening is that the function Python thinks that this line of code is not part of the function. So if we run this code, what will end up happening is this function will be defined, and then 5 will be printed out. But whenever we call this function, the 5th line will not be part of the function. Great. So, okay, that's a bit confusing. So let me do 1 and 0. And so it prints out 1 and 0, and 1 plus 0 is 1. It never prints out the 5. We would, in order to make it be part of it, the function block, we have to include the 2 spaces. But in this case, this line will never get printed out either, because this is after the return statement. Any code after the return statement will not be executed, because the return statement is the last line that will be executed. So if we run this, call mySum of 1, 0, we only get 1, 0, and then 1 plus 0. Great. So here are a couple examples. This is a function that takes in no arguments, and it always returns 0. So let me do this. So always returns 0. So if I call always returns 0 with no arguments, it always returns 0. And if you pass in the wrong number of arguments, you'll get this error saying that it expects X number of arguments, but you give it 1 argument. So you might run into that. Let's look at another example. This function returns the same value, so this is like an identity function. Identity takes an argument and returns that argument. Okay, so identify of 3 is equal to 3. That's great. And then here's another function which is a bit more interesting. It checks if someone can buy beer or not, given their age. So this function would, this is a bit more interesting. So can buy beer. If you pass in something like 10, just return false, because you probably shouldn't buy beer if you're 10. And if you pass in 40, just return true. Great. Okay, now I want you to write a function that returns the sum of 3 numbers. And you can pause this video to get started with that. And then, yeah. Okay, great. So you might have seen the answer, but what you want to do is you want to, we call def sum of 3 numbers, x, y, z, and you just want to return x plus y plus z. And then when we type this in, you can do sum of 3, 1, 2, 3, and this returns 6. Great. Okay, so we have functions, and I'm going to introduce a thing called Boolean Logic. And the reason why we want to use this is that we want to be able to answer questions that depend on multiple expressions. For example, if we want to know if someone is a teenager, we want to know if someone is a teenager if they're greater than their age is at least 13, but at most, their age is greater than or equal to 13, and their age is less than or equal to 19. So anyone who's 13 to 19, they're considered teenager, because it has a teen in their number. So this is how you would define a function that tests if someone is a teenager. And there are a lot of other conditionals. For example, you can do an AND condition. So the way ANDs work is that both statements have to be true for the result to be true. Otherwise, it's false. So the way ORs work is that either statement can be true, and either statement can be true. If either statement is true, the whole statement is true. This is a bit confusing because sometimes someone might ask you, do you want chicken or steak? But what they really mean is, do you want chicken or do you want steak, but not both? So this is actually something called an exclusive OR, and the way to use it is using a caret sign like this. So it's only true if exactly one statement is true, but not both of them. And we can use a not to negate the expression. So if something is false, it becomes true. If something's true, it becomes false. And we can also use parentheses to prioritize an expression to be evaluated. Okay. And let's see. With these operations, we can create something called a truth table. Since for x and y, they can only be true or false, there's 4 different outputs, or 4 different types of inputs x and y can be in pairs of. So in here, if x is false, y is false, then x and y is false, because x and y is only true if x and y are both true. So this is also false because x is false, this is false because y is false, and finally this is true because they're both true. We can do something similar for OR. So OR is true if either is true. So false and false, that means if x and y are both false, then x or y is false as well. So this is true because y is at least one of them is true. This is true because at least one of them is true as well. And this is true because they're both true. And not, this is pretty simple. False becomes true and true becomes false. So now I want you guys to do an exercise where you fill out the truth table for x exclusive or y. Take a minute to do this, and then when you're ready, unpause the video. Okay, so we can easily test this within the REPL. So false XOR false. That should be false because neither of them are true. So in order for this XOR to be true, only one of them has to be true. Exactly one of them has to be true. So false XOR true, this will be true because the second value is true. True XOR false, this is true because the first value is true. True XOR true, this is false because they cannot both be true. Great. And it's very important that we have to, similar to math number operations, there's a order of operations for this as well. So parentheses goes first, then negations, then or and clauses, then or clauses, and also exclusive or clauses are in the same level. Great. So some examples, if you type in not false, you get true. Not true, you get false. Great. And we can also apply multiple statements together. So this is true and false. The way we want to look at this is that if we have and statements all together, we want to operate from left to right. So true and true, that becomes true. And then what we have left is true and false, which is false. So I can do true and false. So what ends up happening is true and true becomes true, and then we compute that with true and false, that becomes false. Great. And next example is quite important because it minds our order of operations. So and the order of operations says that and should be applied first before trues. So imagine if we did this from left to right. Let's see what value we get. So if we do true or false, that would be true. And then when we do true and false, when we do true or false, and false. So the true or false portion becomes true, and then we apply that to the AND clause, and then we get false. However, as you see above here, the actual answer is true. The reason for this is that we need to be applying this in this order. So the false and false becomes false, and then this reduces to true or false, which is true. Great. So now I want you to write a function to determine if age is not a teenager. Pause the video, and when you're ready, unpause it. Okay, cool. So there's multiple ways of doing this. So one of the simplest ways is that we can write a OR statement. So not a teenager means that someone is less than 13 or greater than 19. So let's test this. Not a teenager of 10. That is correct. Not a teenager is 15. That is correct. Not a teenager of 30. And that is correct. Another way of doing this is if we had a function is teenager, and we do have this function way up here somewhere on this page, and this is defined to be return age is greater than or equal to 13 and age is less than or equal to 19. We can define not a teenager to be the negation of is teenager. And when we return that statement, so not a teenager of 10, that's true. Not a teenager of 15, that's false. Not a teenager of 20, so not a teenager of 20. Okay, that's true. Great. Okay, so on to the next section, which is if statements. So if statements allow us to execute certain blocks of code so that we're basically giving our code some logic paths to execute in certain manner. So we can define a function called myMax. What it takes is 2 parameters, and it would return the maximum value. So what this is doing is if x is greater than y, that means x is the maximum input. So we want to return that value. So in the way that if statements work is that we have the if keyword right here. We have a Boolean expression to test. So this returns true or false. If this is true, then we'll execute this line of code inside the if statement. If statements can have multiple blocks of multiple lines, but in this case, it only has 1 line in this code block. And then after if it finishes the if block, it will continue back to the original code where it left off. However, in this example, there's a return statement here, so since there's a return statement here, it will stop execution of this function and return the x value. So if the statement if this Boolean expression is not met, then this return statement, so this line would be, this entire code block in the middle would not be executed at all, and we just jump directly to this line which returns the y value, which makes sense because if x is not the maximum value, then y must be at least greater than or equal to x. And similar to function definitions, we also need 2 spaces to signify a code block. Yeah, that's basically it. So examples, we can write our own absolute value. So if a number is less than 0, we want to negate that number, and otherwise, if a number is not less than 0, it won't execute this line of code, but it will just return the original value, which is x. So my min is similar to my max, except for we'll check if x is less than y, then return x. Otherwise, it'll skip this line and then we'll return y. And then the next section is we want to have a function that returns the maximum of 3 values. And you should pause the video to try to figure out how to do this yourself, and then unpause when you're ready. Alright, I guess you're ready. So, max of 3 x, y, z. So one thing we could do is we could check if x is greater than y and x is greater than z. If so, then we go on to return x. So if x is greater than y and x is greater than z, we want to return x. Okay, so if this is not true, then x is no longer considered to be the greatest value. So we can test y if y is the greatest value. So y greater than z. If so, we want to return y. And if this is not true, then y is then no longer considered to be greatest value, and then we can just return z. Great. So this works. So max of 3, 1, 2, 3, 1, 2, 4. We can even do it like this, and it works. But if we had our other function called myMax of x and y, and we want to return x greater than y, return x. Sorry, if, and then this would be return y. We can update this function to be return myMax of x and y, and then myMax of y and z, and then we can return myMax of the resulting value of those two. Or we can actually do myMax of x and y, and then this return the maximum of x and y, and then we take that and compare it to z, and this should work too. Max of 3 of 4, 2, 4, 2, 3. Great. Cool. Okay, so next thing we'll do is variables, and the reason why we need to use variables is because it's a way of storing a value and updating that value, and also being able to get the value back. For example, if I tell you to remember something, and the next day I tell you what did I tell you, you'll be able to recall that value, and that's very useful to have in this world. So things with variables, that the variables cannot start with a number, it has to start with a letter. The letter could be uppercase, lowercase, or it could be underscore. Following that, the next letters could be lowercase, uppercase, numbers, or underscores. And that's basically it. So let's look at a function that uses a variable, and this function just counts the number of positive numbers. So we initialize it to 0, and if x is greater than 0, we update the count variable to be count plus 1. And we do something similar for y and z, and then we return what the count value is. So this should work. And if you would imagine if we didn't have variables, we'd have a lot of if-else statements. We'd probably have, let's see, 8 different if-else statements. At least, I'm not even sure. Yeah, probably 8. And this reduces the problem to something much simpler, just 3. And that's basically it for today.